Throughout this course, our algorithms learn from labeled data or hidden patterns. Reinforcement learning introduces a completely different paradigm. Instead of learning from examples, an intelligent agent learns by interacting with its environment. Every reinforcement learning problem contains two key components. The agent makes decisions, while the environment responds to those decisions. This robot's mission: find the glowing energy crystal. At every moment, the agent observes its current state, chooses an action, receives a reward or penalty, and moves into a new state. This feedback loop drives the learning process. Unlike supervised learning, reinforcement learning does not receive correct answers in advance. The agent gradually discovers successful strategies through repeated trial and error. A successful agent must balance exploration and exploitation. It needs to discover new possibilities while also taking advantage of strategies that have already proven successful. One classic reinforcement learning algorithm is Q-learning. It estimates the long-term value of taking a particular action in a particular state. Over time, these values guide the agent toward increasingly effective decisions. For complex environments, storing every possible state becomes impossible. Deep reinforcement learning combines neural networks with reinforcement learning, enabling intelligent agents to solve problems far beyond the reach of traditional methods. Let's recap. An agent acts inside an environment. Every action returns a reward and a new state, and trial and error slowly turns that feedback into strategy. Q values store what actions are worth, and neural networks replace the table when the world gets too big. Reinforcement learning powers some of the most advanced autonomous systems ever built. It is used in robotics, transportation, manufacturing, healthcare, energy optimization, logistics, finance, and scientific exploration. From fitting a simple line through data to building autonomous systems that learn through experience, we've explored the remarkable evolution of machine learning. Every algorithm solved a different kind of problem, and together they form the foundation of modern artificial intelligence. Your journey into AI doesn't end here, it begins here.